Well, hi there. This is your most favoriteest math teacher you ever had between the months of August and November of the year 2025, Mr. Baker, coming at you live from my desk. We are going to be talking about solving inequalities today. You guys have done this before back in Algebra 1, maybe before that. It's really pretty much the same as solving an equation. If this problem here just had an equal sign in it, it's for the most part, they're really the same. There's just one little catch we got to watch out for when we do this. We will be talking about like graphing our solutions on a number line and then how to check answers. But for the most part, it's the same. And so we look at something like 2x minus 5 is less than or equal to 5x, and we just want to gather the x's on the same side. So I'm going to subtract the 2x to the other side since it's the smaller of the x terms. And since the x's are going to the left, I want the numbers to go to the right. So I want the 7 to come, or sorry, since the x's are going right, the numbers going to go left. And so I'm going to subtract 7 to both sides. That cancels. We get negative 12 is less than or equal to 3x. And then we're going to divide both sides by 3. And so we get negative 4 is less than or equal to x. And so, it's perfectly fine if you leave the answer that way, but I really would recommend that you flip it around so that the variable's on the left side of this, and then, since the x is, the inequality is opening towards the x here, it just needs to stay that way, so everything flips around. These generally do work better when you write it this way, so just something you might want to make note of. And then we're going to just graph a little number line, nothing fancy here. Generally, I just think about putting like 5 tick marks on here, 5 or 6, and then the number we have here, negative 4, just kind of put in the middle. And so to the left of that would be negative 5 and negative 6. To the right of that would be negative 3, negative 2, negative 1. And since this is greater than or equal to, we're going to put a closed dot on negative 4. And x is greater than that, so we want numbers that are greater than negative 4, like negative 3 or negative 2 or negative 1, so the arrow should go to the right. So that's part of the reason I want you guys to keep the variable on the left side, because if it does, we can follow the arrow here, and it follows there. Like, so it says points to the right, and this also points to the right. That's something that's helpful about that. Do not remember that when we have an equals to, so whether it's less than or equal to or greater than or equal to, that's the closed dot. And then the less than or the greater than is the open dot when we're doing our number lines. So if you don't remember that. And then as far as like the check goes, what I want you guys to do here, so you're not going to check the number that you get. It's like that negative 4. Because if you do that, all we would find out is like if you found that number right. What we want you to do instead is check a number that's in the space. Okay, so I'm going to check negative 3. Generally, I would say it's best to check the next number in the space, like far as, but do not check something don't check the answer per se, but check the number that's in the space. So go back to the original problem. 2 times negative 3 minus 5 less than or equal to 5 times negative 3 plus 7. You're not going to move anything across the inequality sign there. Simplifying each side, so we got negative 6 minus 5, which is negative 11. And here we have negative 15 plus 7, which is negative 8. And negative 11 is less than negative 8, so it checks. Okay. So another little note. So kind of like when I asked you guys when we were doing this with the graphing the systems of inequalities, when you're shading it and you're graphing and then you're finding out that was shaded this way and this one was shaded this way. I asked you guys to check points that were in this space. So it's kind of similar to that, what I'm asking you guys to do here. So, because if you check the number, if you check just the number, like if I check the number 4, we find out that we find out if we've solved that right, but we don't know if our arrow is pointing the right way. So knowing this here will let us know that our arrow is pointing the right way. So, all right, do this again. So I want to get x by itself, so I'm going to subtract 4 here. So I get 2/5 of x is greater than or equal to 8. And to get rid of a fraction here, so this fraction is multiplying, so you may be tempted to divide by 2/5, which is not a good thing to do because most people are not very good at dividing by fractions. So what you do instead is you multiply by the reciprocal of that. So reciprocal of 2/5 is 5/2. And so on that left side that cancels, we're left with x. It's greater than, and then over here on the right side, 8 times 5/2 is the same thing as 8 over 1 times 5 over 2, which gives me 40 over 2, which is 20. So that's where that's coming from. Okay. And so there we're done with that. Number line. In the middle, 19, 18, 21, 22. This is equals 2, so it gets a closed dot, and we need x's that are bigger than 20. So we want like 21, 22, 23, so heading off that way. So the arrow goes that way. So far as check goes, I'm going to check 21. So 2/5 times 21 plus 4 is supposed to be greater than or equal to 12. So 2/5 times 21 is 2 times 21, which is 42 divided by 5. 42 divided by 5 is 8.4. You can just use your calculator if you need to. 8.4 plus 12 is, or 8.4 plus 4 is 12.4. And 12.4 is greater than 12, so it checks out. So our answer works. Nothing too crazy going on there. A bit more going on this next one. We saw some of this back in section 4.2 that we need to simplify each of these sides before we can solve this. So we got some simplifying we need to do here. We got some simplifying we need to do here. Mainly that's combining like terms and distribution. When you're looking at this one on the left side, just, when you're distributing, don't distribute a 2, distribute a -2. And so that's going to distribute there and there. So that's going to be 5 minus 2x and then minus 6. And we do have some like terms there to combine. So 5 minus x, we're going to do what it says, 5 minus 6, which is -1. So we have -2x minus 1. Greater than. And then here, similar thing, when we're distributing, we're going to distribute to -2 again. So it gives me -3x minus 2x plus 20. -2 times -10 is positive 20. Like terms here. So -3x is minus 2x's. -3 minus 2 is -5. So -5x's plus 20. And now we can solve this. I was just simplifying, now we can solve this. So I'm going to bring the 5x's to the left side since that's smaller. Since the number x's are going left, the numbers are going to go right. So I'm going to add 1, add 1. So that cancels there, that cancels there. -2x plus 5x is 3x. 20 plus 1 is 21. And then divide by 3. So x is greater than 7. Number line. So 7 is here, open circle this time. We want numbers that are bigger than 7, so like 8, 9. So So again, the arrow is going to head off to the right. So I'm going to check 8. Go back to the original problem. 5 minus 2 times 8 plus 3 greater than negative 3 times 8 minus 2 times 8 minus 10. Do what's inside the parentheses first. So 5 minus 2 times 11, and then multiplication. 2 times 11 was 22, so 5 minus 22. 5 minus 22 is negative 17. Here we got negative 3 times 8 minus 2 times 8 minus 10 is negative 2. Negative 3 times 8 is negative 24. Negative 2 times negative 2, there is positive 4. Negative 24 plus 4 is negative 20. And negative 17 is bigger than negative 20, so it checks. So we did right. Good. All right. So, next one, get after it. So I want to get x by itself, so I'm going to add 15 to both sides. Get negative 7x is less than 35. And we divide by negative 7. So x is less than negative 5. Okay, that was easy. Another line. Negative 5, negative 6, negative 7, negative 4, negative 3. It says x is less than 5, so open circle, less than, so things that are less than negative 5, like negative 6, negative 7. It's heading off to the left there. And so I'm going to check negative 6. So negative 7 times negative 6 minus 15 greater less than 20. 6 times 7 is 42. 42 minus 15 is 27. And 27 is not less than 20, so something went wrong. So here's the one thing that's different about solving inequalities than solving equations. Right here, this step. So we can see that when we did this, we got answers here that don't work. Whereas if we plugged in something like negative 4, that would give me positive 28, and 28 minus 15 is 13. And 13 is less than 20. So what happens is we need that arrow to be going the other direction. Well, where that happens is right here. I'm just trying to fix this stuff. So what we have to watch out for with solving inequalities is that when you divide, all right, you make that step of dividing by a negative, or really multiplying by negative or dividing by negative, but usually it's division. And it does have to be when you multiply or divide both sides by a negative. The symbol flips. So that's the one thing that's different about solving inequalities and solving equations that we have to watch out for when we multiply or divide both sides by a negative. So it's not that we got a negative answer. That's been a mistake in the past, like, oh, I got a negative answer, I must have to flip things. It's not it. It's not the here, like here when I was distributing a negative 2 here. Because I was only doing that on one side of the problem, and so that does not affect it. It's when I divide both sides by that negative 7 that happens. Or like up here, if this had been like a negative 2/5 and I was multiplying by negative 5/2, then I would have to flip the symbol. So that's when you do that. So that's the only time you got to watch out for that. Okay, but it is super easy to miss, so you have to be really careful about that. That's fun. Okay, so let's try this one. So I want to get x by itself, so I'm going to subtract 27. Negative 1/2 x greater than or equal to negative 14. I just subtracted there, not a problem. Okay? But here, when I go to multiply by negative 2/1, multiply by negative 2/1, that's where my symbol is going to flip, right here. Okay. So that gives me x on this side, and then negative 14 times negative 2 is positive 28/1, or just positive 28. Because that's just over 1 here. So again, not because I got a negative answer, but because I multiplied by the negative here, the symbol flips. Really, really easy to forget. Okay. And graph that line. Close dot on 28. I want things that are less than 28, like 27, 26, so the arrow is going to head off to the left. Then we're going to check 27. Negative 1/2 of 27 plus 27. Half of 27 is 13.5, so it'd be negative 13.5. Negative 13.5 plus 27 is 13.5. And 13.5 is greater than 13. It worked. Okay. Let's skip this one. I'm going to go on to the next side. So what we're looking at here are called compound inequalities. So compound inequalities are AND inequalities. Something like x is greater than 2 and it's less than 4. Or you have what's called an OR inequality, where we say that x is greater than 2 or x is less than negative 1. So here there are lots of numbers that are bigger than 2 and less than 4, like 3 or 2.9 or 3.7. There's lots of numbers that are in this space that do both of those things. But there are no numbers that do both of these things. So you can be bigger than 2, like 5, or you can be less than negative 1, like negative 5. But there are no numbers that do both of these things. So it's either this or you're that. These are called compound inequalities because they're two inequalities at once. Like in chemistry, compounds are mixtures of multiple elements. Okay. Basically, you can solve it the same way, but it's like solving two problems at once. With an AND inequality like this, what you want to do is think about the first part of the problem, first part of the problem, this left side of the problem, from there to there. You're going to solve that. So I have negative 10 less than or equal to negative 3x plus 5. I'm going to solve this. So minus 5 minus 5 gives me negative 15 is less than or equal to negative 3x. So the symbol did not flip because I just subtracted 5. And then I divide by negative 3. Watch out for this. Right. So that gives me positive 5. Flip the symbol around. Is greater than or equal to x. Okay. Then you also do the other half of the problem, which is here. So we have negative 3x plus 5 is less than 8. So subtract 5. by negative 3. Watch out, watch out, watch out, watch out. That gives you negative 1. All right, so I solve both sides, graph that. So I have 5 and negative 1. Usually what I do is it's something like this. 5 would be the bigger number, so it should be on the right side. Negative 1 should be on the left side. I don't need to try to connect the numbers. And by that I mean like put all the numbers between them, unless they're really close to each other. It wouldn't be that hard for me to put 1 and 2 and 3 here. But especially if the numbers are really far apart, I don't need you to connect them. Like it's okay, just have like kind of 2 separate number lines. But look at that green one. X is less than negative 1. Sorry, x is greater than negative 1. So that's open circle. Greater than negative 1 would be to the right. And then the other one, x is less than or equal to 5. And so if I flip that around to make a little bit more sense of that, like this. Close dot at 5. And less than would be to the left. And so, and inequalities do this. They meet in the middle. All right, it's saying that numbers need to be bigger than negative 1 and less than 5, or equal to 5. But we're talking about all those numbers that are in there. And so how we write our answers here, and this is something you need to follow. So you put the variable in the middle, put the number over here on this side. It's almost like I'm copying the number line. And it's greater, it's heading towards x, right? And it's heading towards the 5. This one has an equals sign. Okay. So this is how you write a compound inequality answer for an and. If you check an answer, well, I'm going to check 0, because it's in the space. Negative 10, negative 3 times 0 plus 5. So negative 3 times 0 is 0, plus 5 is 5. 5 is bigger than negative 10, and 5 is less than 8. So we see that worked. Yeah, that's an and problem. The ands always connect. And then when you write their answer, it looks like this. Small number on the left, big number on the right. You have your variable in the middle, and then you have the appropriate signs, like it's always going to open towards the right. Okay? Just when I say appropriate, I mean like does it have a line underneath it? But they always look like this. The inequalities always move towards the right because the bigger things are always to the right when we write this. This number is smaller than this, which is smaller than this. So they always open towards those bigger things. Okay, just depends if they should have lines underneath them or not. We saw on our problem that one had and one didn't. They can both not have them. They can both have them. There's no like rule there, but the rules they do need to follow is it looks like this. Okay. So graphically, they always connect. And then when we write the answer, they look like this. This is really the part about this lesson that you need to remember for what we're doing next lesson in 4-6, is what ands and ors look like. All right, we're going to do this last problem. Really with an or, you just have two completely separate problems. You're just going to solve. So they really don't have too much to do with each other all the time. So I'm just going to subtract 7, or add 7. And divide by 3. The x is greater than or equal to 4. Done with that one. Here I'm going to add 10. So I get negative 2x greater than 10. I'm going to divide by negative 2. Watch out, watch out, watch out, watch out, watch out. So So x is now less than -5. Go to graph this. Two numbers I have are 4 and -5. So start here. 4 is bigger, so it goes on the right. -5 is smaller, it goes on the left. I should have -6 and 4 around it. Here you have like 3 and 5. And I don't need you to fill in the numbers inside. So when I go to x is greater than or equal to 4, which would be closed dot on 4, greater than 4, like 5 or 6 or 7. So it heads off that way. X is less than -5, so open circle on -5. X is less than that, so -6, -7, -8, so off that way. So this is the way ORs always look graphically. ORs always go away from each other. If you were looking at me right now, I'd be holding my thumbs out, one pointing left and one pointing right for an OR. If you're looking at me and I said, hey, what about an and? You'd see me turn my thumbs in towards each other, so one's pointing, they're pointing towards each other. They're touching. My tips of my thumbs are touching. So ands always touch, ORs always point away. When you go to write the answer, just write it from the graph again. So x is less than -5. X is greater than, or less than, sorry, x is greater than or equal to 4. And you put an or between them, because you can't be both. There's no number that's less than -5 and bigger than 4. You can only be that one or the other. So that's how you write your answer. And checking these, you would end up just checking both of this. It's not something you guys really need to worry about doing that. But you would plug in a number and see that it works. Plug in like -6, and you would see that it works in this one, but it wouldn't work here. And then you would plug in a number like 5, and you'd see that it would work in this one, but it wouldn't work here. That's the whole OR business. Okay. So I guess this really is the part that you guys need to know for our next lesson, is what ands and ORs look like when we go to do the solving absolute value inequalities. So you guys have a worksheet for this. You guys have other work you should be turning in or checking, and then you have the extra credit that's available on the Google Sheet, okay, through Excel. Just make sure you log in, and it should be there for you. All right, hope you have a good weekend and get lots done. And I'll see you guys on Monday.